Hello everyone, this is Mr. Pelt, and today I'm going to walk you through this linear programming problem. There's a lot to unpack, so let's get to it. So we have a craftsman producing bracelets and necklets that contain gold and platinum. So the first thing we need to think about is defining our variables. So the problem prompts you for that because it's a little confusing. You might be thinking that the platinum and the gold are the X and the Y, that those are your variables, but they're not. And once we get into the problem, you'll be able to see that. The other sort of clue there is that we're producing bracelets and necklaces. And so that's the variable is going to be how many of those are we producing. So let's just kind of go through all this information. So it says that no more than 120 grams of gold is available and no more than 144 grams of platinum is available. So those are going to determine some of our constraints. And then each bracelet contains some gold and some platinum. And then each necklace contains some gold and some platinum. So that's going to help us determine how those constraints behave. And then we have the company will yield a profit of $90 on each bracelet and $130 on each necklace. Now that's not a constraint on the situation. That's going to be our objective. That's going to determine our objective function here. So let's start with defining those variables. We'll let X represent the number, wrong tool. X represent the number of bracelets. And then Y is going to represent the number of necklaces. And now looking at our constraints. So first we have the constraint on the gold is a way to think of it. So our gold constraint. I don't know why I switched to blue there, but we'll go with it. So our gold constraint is 120 grams, no more than 120 grams. Where does gold get used? Well, each bracelet uses 12 grams of gold. So we're just focused on the gold constraint here. So each bracelet contains 12 grams of gold. So 12 times the number of bracelets plus each necklace uses 6 grams of gold. So 6 times the number of necklaces. So, and all of that combined, so that's our gold, our gold from bracelets, which is 12x, plus the gold from necklaces, that's all the gold combined, and that of course needs to be no more than 120, so it's less than or equal to 120. Then we have our platinum constraint. Our platinum constraint, since I'm mixing it up with colors, I'm just going to go for it. So our platinum constraint is, again, our constraint on our platinum. So we have each bracelet contains 9 grams of platinum. So that's 9 grams of platinum times the number of bracelets, plus each necklace is 18 grams of platinum. So that's 18 grams of platinum times the number of necklaces. I think I said necklaces that time, that's what I meant. And that's got to be no more than the 144 grams of platinum, which is our restriction on platinum. So those are our two main constraints. The others that you shouldn't forget about is sort of obvious, but they're important. You can't have a negative number of bracelets, so the number of bracelets must be 0 or more, and the same with the number of necklaces. Okay. Now the next prompt is for the profit equation. Now we're not going to need that for a while yet, but it's helpful here to just go ahead and write it. So the profit based on some number of bracelets and some number of necklaces is determined by this $90 profit for each bracelet. So $90 times the number of bracelets plus this $130 for each necklace. So 130 times the number of necklaces. Okay, so that's all of our constraints in our profit equation. Now let's get to graphing those constraints. I don't have a ruler on this app, so we'll see how this goes. So let's start with the easy one. So x greater than or equal to 0 is the line at x equals 0. That's the vertical line at 0. And I'm going to do the shading the opposite technique that I've advised some of you about. But I'm going to hold off on the shading just so it's really clear and easy to see. I'm just going to hold off on that for now. Now I'm going to do the y greater than or equal to 0. So the line y equals 0 is this horizontal line where y is 0. And now for our gold, I'll try to match colors here. So for our gold constraint, the 12x plus 6y less than or equal to 120, I'm going to use standard form. Since it's in standard form, I'm going to use the, I'm going to find the, oh my goodness, I can't speak this morning. I'm going to find the intercepts. So if x is 0, if the number of bracelets is 0, I get 6y equals 120. And so y is 120 divided by 6, which is 20. So my y-intercept is 20. And my x-intercept is when y equals 0, so that's 12x equals 120. So x is 10. Those intercepts, again, are really quick and easy to find, which is why I chose that. So I go ahead and plot that point. And now I'm going to go ahead and I don't have a line tool here, so I'm just going to try and do this as accurately as I can. There we go. Now we're going to do the same thing for platinum. And again, I think it's actually a little easier to do this with intercepts. So when x is 0, we get 18y equals 144. So our y-intercept, 144 divided by 18 is 8. So we're at 8 on the y-axis. And then when y is 0, our x, we get 9x equals 144. So our x-intercept is at 16, which is over here. And I'm going to go ahead and try and draw this as accurately as I can. And there we go. And so we've graphed all of our inequalities. Our shaded region, our feasible region, if we look at all the shading, and I'm kind of glossing over this, but you know, if you choose your, sorry, I'm not going to gloss over it. Let's do it. So choosing your, if we use 0, 0 as our test point for that green line, 0 is less than or equal to 144. That's true. So we'd be shading down here below that green area. And then for the gold, same thing. If I plug in, just point to it up here, 0, 0, I get 0 less than 120. That, of course, is true. And so we'd be shading down here below the blue line. And of course, our feasible region then is this area, this region down here. Okay, so now, oops, come on, there we go. Now we need to identify the vertices of the feasible region. That feasible region is a four-sided figure. So we've got one of them at here at 0, 0, another one up here at 0, 8, another one down here at 10, 0, and then this one right here, which if you graphed it nice and accurately, you can read it right off the graph. That one is going to be at 8, 4. And now we can go ahead and do our profit. So I'm going to rewrite our profit equation here. it was 90x plus 130y. And now if you go ahead and plug in your 0 for x and 0 for y, obviously that'd be a terrible idea. You're making 0 profit. What fun would that be? You're also not making anything. For 0, 8, you plug in 0 for the x and 8 for the y. So doing that should get you $1,040 profit. If you do 10 and 0, so 10 for the x and 0 for the y, you get $900 profit. Whoa, why did I put a comma there? Let's try that again, Mr. Appel. There we go, $900. And 8 and 4 is $1,240. And so our final answer there, if we're trying to maximize the profit, it's $1,240. So we would need to sell 8 bracelets and 4 necklaces to reach a maximum profit of $1,240. And that's that. Hope this was helpful. Thanks.